Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to develop a simple combinational circuit on your Zybo board. So let us try to see how we are going to implement that particular combinational circuit on your FPGA. What is the process using the Vivado we are going to see. So this is a board which I am going to work, and this is my Zybo board. And this particular Zybo board has four number of switches and four number of buttons, and this is your main FPGA. And what we are just basically going to, and here your LEDs are present, and each LED is represented by some number, and your switches will have numbers associated with them, and these are your push buttons, and each push button is also having some number associated with this. And yes, so this particular Zybo board which we are going to work, and just we are going to connect your inputs to this particular switches by entering this particular numbers in your constraints, and you can also connect your inputs to this buttons by connecting this particular by writing this particular numbers in your constraints file, and you can connect your outputs to this LEDs and by writing your constraint this numbers in your constraints file, okay, in the Vivado. So this is what we are going to test using Vivado. So for that you need a Vivado tool. So I am creating a new project in this particular Vivado tool, and just I'm pressing next, and I'm giving the project name and the project location, and just I'm going to press next. And here I'm going to create a RTL project, okay. I'm just pressing next, and now I'm not going to add any source for now, and just I'm going to press next. And constraints also I'm not going to add any constraints for now, so just I'm going to press next. And here when so each FPGA has its own part number, okay. So we have to select the part number of your FPGA which you are working with. So present I'm working with my Zybo Z7 board, so that's why I'm going to enter the part number. So I'm going to boards, I'm going to select my boards, and here I can find my Zybo Z7 board. So just I'm selecting it and just pressing next. Yes, so this is how I'm going to select my Zybo Z7 board. Just I'm going to press finish. So your project will be created, and my previous project which I've opened, that will be closed. I'm closing it. Yes, so I've created a project. Now let me maximize this now. So here, this is your Vivado tool after you have created your project. So you have basically two windows. On the left hand side you have flow navigator, and on the right hand side you have project manager. So in the flow navigator you have different options which you have: settings, add sources, language templates, IP catalog. So we'll explore them in detail in our upcoming videos. And on the right hand side you have sources and project summary, and in the project summary you can see the project part number, top module you haven't defined, and project location and project name, and the product family you are using, simulated language, board part number, etc, etc. You can just browse it. And now our main aim is to develop a simple combinational circuit like full adder, and let us try to implement it on your Zybo board. So here after creating this, I'm going to press on this button, and I'm going to press next. So I'm going to create a design source, and I'm going to press next, and I'm going to press create file. So in this particular file I'm going to add my file name as full adder, and going to press OK and finish, and press OK, press yes. Now after opening this full adder, just write down the code for this particular full adder. I hope you are all aware of your verilog coding for full adder. So just you can write down the code for your full adder as input a comma b comma scene, output sum comma carry. Okay, just I'm writing my full adder code, and I'm writing assign sum is equal to a XOR b XOR, and my carry which is equal to a and b, or with b and scene, or with scene and a. So this is my carry equation. Okay, just I'm going to press close this all, and after that's it. So this is your full adder code, sum and carry. So this I'm going to implement it on my board. So before I'm going to implement it on my board, let me save this. And after saving this particular file, you have option called run synthesis. So click on the option run synthesis and wait and press OK. Okay, so it will perform the synthesis, and it will take some time for the synthesis operation to be performed. So we'll wait for that particular time. After your synthesis has completed, you will a window will be popped up like this. So you can just close this, sorry, or you can click on this open synthesized design and press OK. So after opening this, you can just simply go to uh, on the left hand side, you can press on schematic. So a schematic will be open, and in this particular schematic, you can see five IO ports. So just you can press on this particular five IO ports, and so in this particular five IO ports, what you're going to do is here in your Verilog code, you have declared your input ports A, B, and C in, and you have declared your output ports and carry and sum. So basically, you're going to connect them with your board, actual physical board switches and LEDs. So the inputs you are going to connect with your switches on your board, and your outputs you are going to connect them with your LEDs. So and this IO standard, we will make this to LV-CMOS 33. This and all we are going to make it to LV-CMOS 33. Now, and if you have the board available with you, you can just see the numbers, switch numbers on the board itself. Or the board is not available with you, you can just simply go to Google, and you can type for your board schematics. The board I am having is uh, Zybo board. So just I'm typing Zybo schematics PDF. Okay, so the official PDF will be open. So this is a PDF from Zybo. So I'm opening this, and here I'm going to search for my switches. So I'm going to search for SW not SW0. So these are my four switches which are available, and here you can see, right, VCC 3V3, which means 3.3 volts. So that's why here also I'm going to mention, LV-CMOS 33. Okay, and now I want to connect this A with my switch. So that's why I'm going to search for my SW0, the number which is associated with this particular SW0. So I'm going to search further for this SW0. Yes. So the number which is associated with my SW0 is G15. So this is an FPGA bank, which is this is bank 35, and this is Zybo FPGA banks, and the number which is associated with this particular SW0 is G15. So let me connect it with G15, and let me connect B to one more switch. Let's say it has HW1. Let me search for HW1. Let me search for HW1. Yes, so HW1, the number associated with it is P15. So I will write down here P15, P15, and let me connect my C in to one more switch. Let's say it has HW2. So it is W13. So I'm going to connect it with my W13. Okay. Sorry, this is my output, not this one. I'm going to connect it my W13. Okay, scene I'm going to connect it my W13, and my sum I'm going to connect it one to an LED. So I will type for LED. So let me search for LEDs. Yeah, so these are my four LEDs which are available with me. So I'm going to search for LED 0. Yes, so it is M14. So I will type M14 here, and I'm going to search and I'm going to search for one more LED 1. That is M15. Yes, so this is how I'm going to connect my switches to my inputs and LEDs to my outputs. So after connecting my switches and LEDs to my switches and after connecting my inputs to my switches and LEDs to my outputs, I'm going to save this by pressing Ctrl and S, and I'm going to press OK. And now I'm going to save my file name. So let's say it is adder underscore constraint. Okay, and I'm going to press OK. So in the sources, if you see in the constraints section, a file will be created, a XDC file will be created. So you don't need to worry about this particular coding. So the tool will automatically create this particular coding. Just you need now to generate the bitstream. So press generate bitstream and press yes. Okay, so bitstream will be generated, and wait for the bitstream to be generated. And after your bitstream has completed generating, you what the next step you can do is you can just press on open hardware manager, and again you can press OK. And yeah, so after that, connect your board with your laptop and just connect it. Yeah, and after that, click on open target and press auto connect. So your board will be connected with your tool. It will take some seconds. So after that, there is one option which is known as program device. You can press on that and you can just press program. So the bit file which you have generated will be uploaded in your FPGA. Now let us see our outputs at your FPGA, what you are getting. So we have connected our inputs A, B, C to these three switches, and your output sum and carry here. So I'm going to provide my A, so your output is equal to 1. And I'm going to also provide B, A and B. So sum is equal to 0, carry is equal to 1. And I'm also going to provide my C, so sum is equal to 1 and carry is equal to 1. Okay. And if you made all to 0, then your output will be equal to 0. So this is how you are going to implement your full adder on your FPGA board. So that's all about this particular video. So if you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you.